After downloading the CAD models folder from the Google Drive, you will find several types of files within the folder. The step files are the original files downloaded from McMaster-Carr, with the part number leading the file name. These are converted to Autodesk Inventor files. The vacuum chambers and the Crooks tube models are contained within the Autodesk assembly files. Opening these in Autodesk Inventor, you will see the models of the vacuum chamber and the Crooks tube, as well as a model of the Crooks tube with an illustration of the electron beam path. Autodesk Inventor Professional can be downloaded for free for students and educators. Looking at the vacuum chamber model, we can select a cross-sectional view to observe the internal structure of the vacuum chamber. Here we see the flare nut, which couples to the vacuum pump, the hoses, the vacuum valve, the lure lock quick connect fitting, the syringe body, and the plug and electrical feed-through assembly. The flare nut is composed of a brass flare nut assembly, a plastic bushing, which allows coupling to the vacuum hose. The plastic bushing is supported by two fiber washers placed within the nut assembly and is sealed against the flare fitting with a Viton O-ring contained within the nut. This also serves to retain the plastic bushing fitting within the nut assembly. The vacuum to the pump can be turned on and off by means of the vacuum valve. When the vacuum valve handle is parallel to the vacuum tube, the valve is open. Rotating the handle perpendicular closes off the valve. The lure lock type quick connect fitting is a twist lock fitting which twists into the tip of the syringe, connecting the syringe to the vacuum line. The plug assembly contains a rubber stopper with two holes through the body. Two hex head cap screws are inserted through these holes, acting as electrical feed-throughs. Once the screws are tightened by means of the nuts on the opposing end, the head of the screw creates a firm vacuum seal against the rubber stopper. Two nylon bushings provide insulation, preventing plasma discharge between the bases of the screw. At the tips of the screws, two Teflon O-rings separate the hex nuts and the nylon spacers. This is due to the fact that when wet sodium hydroxide is placed on the hex nuts for a demonstration of sodium emission lines, the absence of the Teflon O-ring will cause arc tracking on the nylon at certain pressures. The presence of this O-ring has made the demo more reliable. The Crooks tube is assembled in very much the same way with a vacuum line, a stopper, a syringe body. However, now an electrode is placed through the tip of the syringe and a fluorescent screen is placed within the body of the Crooks tube. The vacuum line used for the Crooks tube is the same vacuum line used for the vacuum chamber demo, with the flare nut, vacuum hose, valve, and lure lock quick connect fitting. However, in this case, the rubber stopper on the Crooks tube has one lure lock to hose barb fitting adapter to allow the vacuum line to be connected to the stopper end. A shortened version of the hex head cap screw is also inserted in the stopper, allowing the feed-through for one electrode of the Crooks tube. On the other end of the Crooks tube, a sewing needle is pushed through a lure lock stopper, acting as the opposing electrode. Ensure that when inserting the needle through this stopper, that the needle is inserted directly straight through and not bent off to the side, as that can create leaks at this where the needle is inserted through the stopper. The fluorescent screen is assembled as per the assembly diagrams. When the Crooks tube is operated, electrons emitted from one of the electrodes are emitted in a conical shape, accelerating towards the disc in the Crooks tube screen. However, a slit is present in the screen, allowing only a fine, narrow filament of electrons to be projected through the screen. This electron beam can be bent with a magnetic field as it moves from the right to the left on the screen, and as this is subsequently collides with the surface of the fluorescent screen, the green glow occurs on the screen surface, illustrating the electron beam path. This may be either straight or bent with a magnetic field, as shown here.